Hello everyone, welcome to another ATRA webinar. Today's presentation is sponsored by Seal Aftermarket Products. Let me play you a short video from Seal Aftermarket.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments, please send your emails to webinars@atra.com. Any questions during the webinar, feel free to text them over to me, and I'll try to answer those the best that I can. And here's the schedule for the rest of the webinars for this year. Next one being March 1st on the 6T40 internal. Doing something a little different this year. We're holding them all on one date instead of having them in 2 days. We're going through all the webinars in one day. See you in Paris at the Paris Hotel in Las Vegas from October 27th to the 30th. That's where we'll be holding the Expo 2016. Today's presentation, we're going to talk a little bit about the Lineartronic Gen 2 introduction. This is the smaller CVT version of the Gen 1. The Gen 2 is about 100 millimeters shorter, and it's about 15% lighter than the Gen 1. It's designed to fit into a smaller chassis behind the smaller engine vehicles. To identify the Gen 2, use the tag number located on the bell housing, also known as a TR580. Power flow is a little bit different on the Gen 2. It goes through the input shaft, which has the forward clutch attached to it. On the Gen 1, we mentioned it had an input clutch with no friction plates. It was steel on steel. You won't find an input clutch on this transmission. It works strictly off the input shaft and forward clutch. Now, the reverse clutch and planet are connected in front of the primary pulley. This means that the pulley's rotation changes between forward and reverse. Having the forward and reverse clutch in front of the pulley cuts down on any engine drag in neutral and park because the pulleys aren't rotating in those ranges. Now, all the weight and load of the vehicle directly affects the secondary pulley. The valve body on this unit is underneath the valve body cover on top of the transmission. Completely different from the Gen 1. Now, the information on the Gen 2 CVT valve body is hard to find because it isn't published. Subaru does not make it available because they sell the valve body, not the individual components. You need a solenoid or you find a worn out valve. There's no fix available at this time in the aftermarket, which means you'd have to replace the entire valve body from the manufacturer. At HRA, we try to find ways to overcome these problems. We're publishing the information to make it easier for you to find the root cause of failure when you're rebuilding one of these units. Now, removing the valve body with the transmission still in the car doesn't look easy because the valve body is on the top of the transmission. Subaru has a special cloth sheet for this procedure to cover the engine and keep dirt out of the transmission. Now, it's important that if you do remove this cover in the vehicle, you're going to want to clean off the cover and the area around it so that when we do pull the cover up, that we're not going to get any debris into the trans. You also need to take the throttle body off to provide enough clearance to remove the valve body. It isn't easy, but it is possible if necessary. The valve body is under a sound shield and that aluminum cover that you see here on the right. Once you remove the sound shield, the 12 10mm bolts on the cover, you're going to pull the cover up and then unplug the valve body main solenoid connector. Next, we're going to remove 9 10mm head valve body to case bolts. Make sure that you do not remove all the bolts. If you remove the other bolts, small parts from the valve body may fall down into the transmission. With the valve body removed, you see that there's 2 O-rings in the case. Now, these O-rings may be stuck on the bottom of the valve body. In either case, we want to make sure we don't lose them and that they do get replaced during overhaul. Now, we have the solenoid identification and function, as well as the temperature sensor, which is part of the internal harness. This sensor is typical thermistor type, so it's no big deal there. It's something we're used to dealing with. As you can see here at the bottom of the photo, the temp sensor is part of the main harness. Now, we have 4 solenoids that you can see here on the lower side of the valve body, but there's 2 others that are located in the middle valve body. Well, actually, one's located in the middle valve body, and there's one located inside the lower valve body. Now, the one inside the middle valve body is the forward reverse solenoid, and then you have your secondary line pressure solenoid on the inside of the lower valve body, and we'll get to those in a moment. Now, once you have the valve body in the bench, go ahead and flip it over. Now, you'll see most of the solenoids are there that we showed you previously. There are 6 solenoids in total mounted to the valve body to control the transmission operation. Now, the solenoid that we're showing you disassembled there was done for presentation only. This is not designed to be taken apart. We just wanted to show you this particular solenoid because it's unusual, just like the Gen2, and that's the secondary line pressure control solenoid. It actually has the pressure regulator valve in the snout. Now, this solenoid operates at about 2,000 hertz, and it controls an orifice with a needle and seat. Now, the orifice controls the position of the pressure regulator valve, which obviously controls line pressure. Solenoid measures around 5 to 7 ohms. It'll have a single red control wire going to the solenoid, but the solenoid itself is grounded through the valve body. Now, for some of the other solenoids, we have the forward-reverse linear solenoid. Now, obviously, that's going to control the forward and reverse regulating valve. Now, the manual valve directs the regulated oil from that valve to the forward and reverse clutch, depending on where the position of the manual valve is. The lockup duty solenoid controls the position of the lockup slip control valve. When the solenoid is off, fluid pressure applies to the release side of the torque converter, releasing the converter clutch. Now, as soon as the duty cycle starts to increase, It gradually moves the lockup slip control valve to close off the apply circuit. This will open up the release circuit. Now this bleeds the pressure from the release side of the converter, allowing it to apply the lockup clutch. Now the lockup duty solenoid should measure anywhere between 10 to 13 ohms. This solenoid has two wires, a light green and gray wire going to it, and the solenoid is normally closed. The primary up and down solenoids work together to control the transmission ratios. Obviously, they're controlling pressure to each pulley. Line pressure enters the primary pulley shift valve and becomes primary pressure controlled by the primary up solenoid. This is the upper valve body. After you remove all the bolts on the lower side of the valve body, flip it over, remove the bolts from the upper section. Now once we remove the upper section of the valve body, inspect the valves and the bores. Like I said, we don't have at this time aftermarket fixes for any worn valves, but if we're going to reuse the valve body, it's best to take these valves out, make sure there's no worn bores that we can, so we know for sure we can go ahead and reuse the valve body. Now in this section of the valve body is the primary down, primary up valve, forward reverse regulator, transfer case clutch slip control, and the torque converter pressure and fail-safe valve. We give you all the spring dimensions in your handout. Again, this information is not available from OE. This information was all compiled here at ATRA. Now for the middle valve body, look for some small filters and relief valves in the middle section. As you can see, we have 4 relief valves. Each spring is a different dimension. So we give you all the dimensions. The springs go down in the valve body first. The same with the 3 filters that are located inside this section, and the springs go down first on those also. So we have a pilot valve, forward reverse limit, primary relief, the lube drain back, and the torque converter clutch control and regulator valve. The lower valve body section, this is where the secondary line pressure solenoid is located. You can see the solenoid through the side of the valve body here, but you still have to remove the 2 bolts and that plate to get the access to the bolts for that solenoid. The only valve found in this section is the lube check valve. Just like on the Gen 1, we have 2 bulkhead connectors on the top of the case. These connect the transmission harness to the transmission control module harness. The brown connector is the T3. It contains the inhibitor switch and speed sensor signals. And the gray connector is the T4, and that's for the transmission solenoids and the temp sensor signal. Now the inhibitor switch is on the passenger or right side of the transmission. Now, obviously this switch inhibits the starter operation and operates the backup lights. It also tells the TCM what range the transmission has been placed into. Okay, there are 3 speed sensors located on the left side of the transmission. All 3 speed sensors have a common ground and a common feed. They produce a 5-volt square wave signal. The turbine speed sensor reads input speed. Now this sensor creates a signal from the side of the forward drum. Obviously the forward drum is connected to the input shaft. What we're showing you here on the lower right is that sensor is aligned with that opening that you see in that housing so that it can monitor the lugs on the forward drum as it turns. Then we have the primary speed sensor that reads the speed of the primary pulley, and it creates its signal from the exciter ring that you see here attached to the primary pulley. This is something that we should take care with during assembly or when the parts are being cleaned. We do not want to bend any of the teeth on that exciter wheel. Then that leaves us with the last speed sensor, the secondary speed sensor, and that monitors the secondary pulley. And the sensor pickup is the reduction gear itself that's splined onto the secondary pulley. And still on this left side of the transmission, we have the secondary pressure sensor. This measures the secondary pressure, or as we call it, the line pressure. This sensor has a 5-volt power source and ground, and the signal wire ranges from about 1/2 volt with no pressure and close to 5 volts or approximately 4.5 volts at maximum pressure. When one of these units comes in with a problem, always start by checking the fluid level. After that, you need to make sure that the secondary pressure or line pressure is correct, and the secondary pressure port is on the left side of the transmission, just under the secondary pressure sensor. This is where we have to be cautious. This transmission developed in extremely high pressures. You need a special gauge and hose rated at least 1,000 psi. Now, for safety purposes, you can use a pressure transducer instead of an actual standard gauge. When running pressure tests, compare the pressure readings from your scan tool to the actual gauge pressure. Now, if the pressures aren't close, make sure you check the power and grounds to the secondary pressure sensors. They are known to fail, and if all the voltage levels are correct, then go ahead and replace the sensor. But the information that you see in your scan tool or software is going to be information that the TCM is getting from that pressure sensor. Now, to take pressure readings, bring the transmission temperature up to at least 140 to 175, and then check your pressure readings at that point. In park and neutral, with the throttle closed at idle, pressures should be between no less than 72 up to 218 psi. In drive or reverse at stall, pressure should be no less than 652 to as much as 870 psi. And you can see here, this is where our pressure port is for the secondary pressure, and there's our transducer right there, or our pressure sensor. Now, as far as transfer case pressure test, if the transfer case clutches chatter on turns, which is something not unusual to us working on Subarus in the past, and basically this one is the same way, even though it's a CVT. If there does chatter on turns and there's no power at the rear wheels, check pressure at the transfer case clutch pressure port. Remove the plug. It has an 8mm Allen head. We give you the part numbers if you want to get the OE pressure gauge setup. There's 2 adapters, one for hose A and B, and there's also a pressure gauge adapter and a pressure gauge assembly. So you have all the OE part numbers for that if you do want to get those from Subaru. If you'd like to make your own adapter, the plug is 13mm with a 1.5 thread pitch. Now, some models may have a front-wheel drive test mode for use with the scan tool. Obviously, we will need a capable scan tool or software on some of these models to be able to use this. So when it's in the front-wheel drive test mode, just like previous Subarus, the transfer pressure should be 0 at all times. So if the transfer case clutch pressure is at 0, the duty cycle, it should be at 0 also. When the transfer case clutch solenoid duty cycle starts to increase or rise, pressure should also increase with it. There should be no delay between the two. So as soon as you see the percentage go up on the solenoid, you should see the pressure rise on the gauge at the same time. So at approximately 60% duty cycle, you should have no less than 58 psi to as high as 102. and then we're at about almost max, 95 to 100% duty cycle. We should have no less than 145 psi to as much as 174. Again, like I mentioned before, when in park and neutral, you should have zero pressure at closed throttle. And you can see right here at the top of the extension housing on the left side is where the transfer case clutch pressure port is located. Now, unlike the Gen 1, there are only 3 sections to the Gen 2 models. You have the torque converter differential housing, the main case, and the extension housing. The difference with the Gen 1 is in between the main case and the extension housing was a smaller intermediate case. Just like the Gen 1, we started at the back of the transmission to get to the transfer clutch assembly, which is located here at the rear of the trans. Simply remove the tail housing. Unlike the Gen 1, there's no hidden bolts here. We just remove the extension housing and you can get access to the transfer clutch and the drive gears in the back. One thing we want to mention that there is an O-ring on the back of the case. We want to make sure that we don't mislocate that and that it does get replaced during overhaul. Now the transfer case assembly as well as the 2 gear sets slide right out of the case very, very easily. Be careful with the gear sets that they don't fall out during disassembly and cause any injuries. There's no need for any pulleys in this section. Now there's shims that go between the bearing on the transfer clutch assembly and the park gear. Make sure that these don't get lost and they're put back in the same locations that they come from. There's also 2 plastic step sealing rings on the bottom of the transfer clutch shaft. As you can see in the photo, these rings are scalloped. One of the things that we really have to pay attention to is not so much an issue with the rings. If they're good and you want to reuse them, that's fine. They should be bore fitted in the section where they go to make sure they fit good and tight. But the important part is the actual ring grooves. What we've seen is we'll have the original rings sitting here and they'll air check better than brand new OE rings. And that, in most cases, what we find is there's actual damage to the ring groove. And of course, the original ring is worn into that groove, so it'll seem to air check better. If there's any damage to the grooves, then the shaft or the drum should be replaced. Okay, this is the transfer clutch drum. Looking inside here, we have 4 clutches. We have 1 molded rubber apply piston and a molded rubber balance piston. Obviously, this is a turning clutch, so we need a balance piston for that. There's no bevel plates in here, just flat steels and pressure plate. Next thing we need to do is remove the main case. And what we're going to do first is remove the rooster comb spring from the linkage. And then with that out of the way, we can rotate the rooster comb, and with a punch we can remove the roll pin that holds the parking rod and rooster comb to the manual shaft, or to the main shaft coming through the case. Now the shaft doesn't have to be removed, just the rooster comb spring and the main rooster comb and park rod. Now, the next step, the factory manual recommends removing all 3 of the bolts you see here holding the baffle plate. This baffle plate does not come out through this opening in the case. It actually stays with the pulley as we remove the main case. So I kind of left the bottom right bolt not snug, just hand tight, so that I did have some looseness between the baffle plate and the case here. I didn't like the way it was flopping around with all 3 bolts removed, so I left 1 in there just barely hand tight. Now you can either remove the manual valve or push it back out of the way. Again, it's up to you. I found it easier to only remove 2 of the 3 bolts for the baffle plate. So as you can see here on the right, we have our filter and pan off. Rooster comb, spring, and roller has been removed. Our rooster comb and park rod, and then obviously the pin that goes to the shaft, but the shaft can still stay inside the case. Now, as you see with the main case removed from the front case, by leaving that 1 bolt there left, this didn't fall out of place, it kind of just stayed there. We didn't have to worry about that. I found it much easier to work with it that way. Let's take a look inside the main case. As you can see, we have our pulley sections and the rest of the clutch assembly still on the front case. And we're going to take a closer look inside. And there's 2 more sealing rings we have to look at. There's 1 in each location here, as well as a filter cover. And it has a gasket underneath that cover, and there's also an O-ring on the lube filter that has to be changed. This filter should also be changed, as well as the sealing rings during overhaul. Now, with the case out of the way, on top of the secondary pulley there are 2 shims, 1 retainer, and a bevel plate. The bevel plate actually holds pressure against the reduction gear. Even though this reduction gear is splined to the secondary pulley, it does slide right off. So since the speed sensor is looking at that gear, the only thing that this bevel plate could be doing is just preventing any vibration from that gear. There's a little bit closer look at the shims and retainer, and as you can see, the gear simply slides right off by hand. Now, compared to the Gen 1, removing the pulleys on this transmission is a little more difficult. Although we're still going to use the same tool we see on the right, we can't actually use it until after the pulleys have been removed, and let me kind of explain that. As you can see here, the secondary pulley, this is the spring-loaded piston, or the spring-loaded side of the pulley. Now, Subaru has a tool that they developed that goes and pushes this down to be able to remove the chain, and then we could go ahead and remove our pulleys. They've discontinued the tool. Apparently Subaru doesn't repair these, they just replace them with remans. So what we had to do is we had to remove these bolts that you see here holding any of the tubes and the bearing retainers to the pulleys. So we took all those bolts out and kind of shimmied the pulleys off. So they kind of look like this here on the right hand side. So we have all our pulleys, our chain assembly, everything removed. Now with the puller tool that we showed in the previous slide, we can go ahead and hook that to our primary pulley, pull back on it, and then take our chain off. Going back was a lot more difficult. Obviously with the chain and everything on there, you kind of had to try to shimmy everything back in place and put the bolts back on once the pulleys were down on the front case. Very similar to the Gen 1, just the primary pulley. As you can see, we have a couple of seals here. They should be changed during overhaul. Even if you didn't have a kit for this, you would at least want to pull the pulleys apart to clean any debris out of them, and also to make sure if the seals are okay and there's no damage, that we could just go ahead and reuse the pulleys. Same thing with the secondary pulley assembly. There's the large spring that we were talking about earlier, and we obviously have a couple of seals here. We have a sealing ring here, and we also have a D-ring that goes onto that piston there. Okay, with the pulleys and everything out of the way, the only thing that leaves on the front case now is the reverse clutch housing and also the manual valve housing. We're going to go ahead and take all the bolts out of the reverse clutch housing, and you can see here on the right-hand side that we just lifted it up, flipped it over, and you can see there's another thrust bearing, a washer that goes there. The way you see it here in the photo is the way it goes back. That's the direction of the bearing and the location of the washer when it goes back. The only thing that leaves now is the double planetary and rear gear, ring gear assembly that was showing you in the upper right photo. Now, what we did next was we removed the 4 retaining bolts holding the manual valve housing to the reverse clutch housing. We did this just to show you that there's really no small parts or check balls or anything underneath it. There's just one plate, there's no gaskets. So they're just taking that apart and put that off to the side to clean it up. Now we started to disassemble the reverse clutch assembly. We had 4 clutches and steels along with 1 beveled plate. Now there's only 1 molded apply piston here, no balance piston. Obviously this is not a rotating clutch. It's just a brake clutch. So now we just simply remove the ring gear and the thrust bearing. Again, the location of the directional location of the bearing and the ring gear, as you see here, would be picked up and flipped down right there on top of the double planet. Now we can remove the double planet and the sun gear, and that's the direction that the bearing and sun gear would go into the planet. Also at the bottom we've shown you a lube retainer that's on the top side of the planet that's held in with that snap ring. This is going to want to be removed to clean any debris that might be underneath that. So now that takes us to the forward clutch assembly. Again, very simple, lift it right out of the case. Not a problem, slides right out. And what we found here is this 1 small sealing ring on the back or the rear side of the forward drum shaft. Then there was 2 larger sealing rings. There's 1 thrust bearing. Now if that shaft was, input shaft was facing straight up, that bearing would be lifted like you see it on the bench and just placed right onto the drum. There's 3 more smaller sealing rings on the input shaft, and then 1 O-ring in the front of the input shaft. Obviously that's for sealing the converter clutch circuit. Only 3 clutches and steel plates, 1 bevel plate inside the forward drum. Of course now this is a rotating clutch, so we have 1 molded apply and balance piston here. Okay, just a reminder also that there is 1 small sealing ring we're showing you here on the right, and then there's 2 more O-rings to seal pressure on the front case. After removing all the bolts from the drive pinion retainer housing, we lifted that off the front case, flipped it over on the right. You can see the pinion gear. And now that takes us to the rear side of the converter differential bell housing. And there's our ring gear. We also have 2 more O-rings in this section. Make sure that we don't mislocate them and replace them during overhaul. Now we can swing the bell housing around to look at the front side. As you can see here on the right, the flaps on the torque converter is what's going to turn the drive sprocket, because this still is a chain-driven pump. So now what we've done is remove that front cover, and you can see the front pump is on the right, and the stator shaft is actually pressed into the differential case. Now the pump drive gear ratios are 133 to 1, and you can see the drive sprocket where the flats for the converter would go. Then you have the chain and the driven sprocket that would spline right down there on the front of the pump. We always want to make sure that we check for any wear or damage to the stator support. Now we just removed the 4 large head bolts that are black in color. Now you may have to pry a little bit on the pump. It wasn't that difficult, but it's slightly stuck in place because there's a gasket underneath. Once we pried it away, you can see the gasket that I mentioned already, and there's 2 O-rings underneath the pump for the inlet and the outlet. Now we remove these small gold-colored bolts, and we can split the pump apart. Came apart pretty easily. You can see the outer gear in the bottom left has some lube pockets in it. And we want to make sure we don't lose the keyway for the inner pump gear. And that's the pump completely disassembled there on the right. The way you see the gears, even if the gears look the same on both sides, I always like to make sure I put them back the same way they came out. So when I remove something, I always lay it on the bench facing the way that it would go back. One of the questions was, is it common for the pinion and differential ring gear to be burnt out on these? Yes, that is one of the most common problems. I was going to get to that in a moment. And like I just mentioned, the main reason that most of these transmissions show up in the shops is because they've been to one of these quick loop centers and they've had the service done on it, where they'll put it up on the lift, they'll pull all the drain plugs out, put them all back in, and then not fill the front differential. Now, to service the front diff, there's a different drain plug on the bottom. It uses a T70 torque bit. After the fluid's drained, we want to reinstall that plug, torque it down to about 52 foot-pounds, and then remove the check overfill plug. That's an 8mm Allen. Once we remove the fill plug, this is the fill plug on the right-hand side of the trans, right by the axle, and this is why it's overlooked. With the axle in there, it's still accessible, but it always gets overlooked in a lot of the quick lube places. That's an 8mm Allen socket for that also. Differential takes regular 75-90 gear oil. We're going to fill it through that hole until it starts to drip out through the check level plug. It only requires 1.43 quarts for a dry fill on the front diff. Service the transmission is a 14mm drain plug. And obviously you can see that, like we mentioned before, the filter is right underneath the pan at the bottom. That center tube that you see on the filter is designed to break up any air bubbles that may be caused from the drivetrain turning and the chain turning. Put our drain plug back. Over here on the left side of the trans, you'll find an 8mm fill plug. We're going to go ahead and remove that. Just start the engine up, run it through some of the gears, after we've already added some fluid that started to drip out. And then we're going to let the transmission warm up to at least 95 to 115 degrees. And then we're just going to add fluid until it's level with the bottom of that fill plug hole. Put the fill plug back, tighten it up. I suggest you use the CVT F fluid from Subaru. Total dry fill would be about 13.1 quarts. And special thanks to Robert Bateman at Seal Aftermarket and Jared Warren here at ATRA for all their help with the pictures and the information for this webinar. And that about does it for today's presentation, sponsored by Seal Aftermarket. If you have any questions, please go ahead and text them over to me. If not, I'd like to thank you all for attending. I really appreciate your time, and hope we see you at the next webinar.